Now, what the sixth step has to do with is creating what is known as a relational model diagram. Again, this diagram is actually based on mathematics, and it is based on what is known as the relation. And a relation is defined as a two-dimensional table. And there are rules as to what is and what is not a relation. A relation consists of rows and columns. Rows, or another term that's used, is tuple or tuple. It's tuple. It consists of rows and columns. There are certain rules in that no two rows should be identical, no two columns should be identical. Columns should not have repeating groups. There are a lot of different rules. However, the way that I have actually structured the design process is such that the entity that you have can be easily transformed into a relation. As long as your entity has a primary key, and remember we said each entity should have a primary key, it will automatically be a relation. We also talked about entity instance. Each row is an entity instance, and the columns are the attributes. And there are certain rules we discussed about attributes when we were doing them. I remember we talked about repeating groups and those kinds of things. And it should each column should only represent one thing. As long as you stick to those rules, you can transform an entity into a relation. So we're moving now from the ER diagram to the RM diagram, where we were talking about entities, and now we're actually talking about relations. So each entity becomes a relation, and a relation is a 2D table containing rows and columns. Relations are also related to each other. There are one-to-one, one-to-many, and many-to-many relationships. However, in the relational model, it only actually allows for us to do these two. We have to do a little bit of trickery to get the many-to-many. This is accomplished using a join table. Because you notice most of the relationships we were modeling were optionality, cardinality, 1 to 1, 1 to n, 0, 1, 0, n. There is no n, many to many. This is accomplished using a join table, and it's going to be one of the first things that we look at to show you how to represent a many-to-many relationship on a relational model diagram that is based on an entity relationship diagram. So this is what we need to start. Now, the question is, how do we take the ER diagram and translate it into a relational model diagram? Again, we're going to use an example, and the favorite example with the employee and the position. Okay, now this represents our simplified ER diagram. It does not have the optionality and the cardinality on it. Now again, let's bear in mind what we have. We have one-to-one relationships, one-to-many, and many-to-many. Let's start with this one here, many-to-many. This is the easiest to translate. And a many-to-many relationship is represented when we have a cardinality of n on both ends. Now, let's say, for example, the two colons. We have n there and n there. The optionality doesn't really matter. in representing, in looking for the many-to-many relationship, you look at the cardinality. The optionality does become important when you're deciding what type of crow's foot to put in there. But that is a minor matter. It is not as important as the cardinality. So cardinality on your diagrams is very, very important. And let's say we use 0 on both ends to represent can. So this is always how a many-to-many relationship is identified on an entity relationship diagram. Remember, your detailed ER diagram looks like this. You have your entity, you have your relationship, you have your entity, and then your optionalities and your cardinalities to indicate the assertions and the details and the specifics of the relationship. This, with n on both sides, represents a many-to-many relationship. Now, this type of relationship, I said, is very easy to translate into a crow's foot diagram. What you do is you replace the diamond with a new entity. That's the first thing you do. So we take out the diamond and we create a new entity. That new entity, I usually combine the two names to give that entity that name. Employee positions or employees positions. Combine the two, and that's the name of the new entity. I'm just going to put the shortened form here. Now, what actually happens is, because this is a many-to-many relationship, there is something called the crow's foot, and the crow's foot appears on this end here. The crow's foot, looks like this. There are different versions that I represent in the book. You can examine it for detail. But on the board here, I will represent all of them like this. There can be a 0 down there, or they can be a 1. 0 representing can from this part here, and the 1 representing must from this one, if it was like that. The solid and the dash represents whether it's identifying or non-identifying. That is important. Identifying relationships usually take the primary key and put it in the new entity. And that is the next thing that happens. Because we are creating a new entity, the primary key from both of these must appear in the new relationship. So what we will have over here is the employee ID and the position ID. You can give them the same name, you can give them a different name. Now, additionally, what is optional, and some designers like to do this, is to create a third key which they represent as the primary key. Let's say I just call it, for argument's sake here, ID. Some designers will always create an ID key, and this ID will be the new primary key for the new entity. That is what some designers like to do. The reason is to avoid confusion and ambiguity. The other thing that designers do is you can create now with this a new composite key. That is, if you do not have an ID, you can have a new composite primary key where each of these becomes both a foreign key and a primary key. FK, PK, FK, PK. So they are both foreign keys and the primary keys, but they combine together to form the primary key, which is a composite primary key. You can use either one. However, you need to be careful in that you have to ensure that there is no possibility of there being duplicates of both of them. In this particular case, an employee can't work in the same position twice if we have both of them as a primary key. That is why some designers always just put in an ID, call it a new ID, and it always allows for the combination to be true. I don't have a problem with that. So to be on the safe side, just create a new one, call it ID, and that can work as well. However, these two now will then be what we call foreign keys. Because the primary key comes from here, it goes there, and once the primary key goes over, it is now a foreign key. Because by definition, a foreign key is a primary key in another table that is also involved in a relationship between the two tables. And the same thing happens over there. Right, so we're looking at one-to-many relationships. And one-to-many relationships mean that one entity instance is related to many entity instances. And from our detailed ER diagram, they are identified two ways. By 1 on one side of the cardinality and by n on the other side. Alternatively, it can work the other way around, where we have n and we have 1. Sorry. Previously, we had two n's on both sides to represent many-to-many. Now, to represent the one-to-many, there's a cardinality of 1 on one end and a cardinality of n on the other end. And it can also be reversed. Either instance gives us a one-to-many relationship. However, how things play out after is determined by where the cardinality, the many side of the cardinality is. And also where the many side of the one cardinality is. For argument's sake, we will put 0, 0 as in can, and here 0 and 0. Now with these one-to-many relationships, you look for where the relationship is 1. You look for what is called the one side of the relationship. To make things simple, let me get rid of this. Right. You look for the one side of the relationship. And wherever the one side of the relationship is, it takes the relationship and it is absorbed and you get a foreign key. In the book, I draw a nice little circle, or I draw a circle. Here I'll draw a semicircle to indicate that the relationship comes this way. And because the relationship is being absorbed into this entity, always the one side of the entity, you get, it brings something with it. And what it brings with it is what we call the foreign key, and that is the position ID. So the position ID becomes part of this here as a foreign key. And what we do is we get rid of the relationship and replace it with a crow's foot. And because this was the one side of the relationship, and because the primary key becomes a foreign key over here, the crow's foot then appears there. And whether or not we have a dash or a 0 depends on whether or not we have can or must, as I explained here. Let me just indicate that here. This is can, this is must, and can 0, must 1. That makes it pretty easy to remember. We do this normally in Visio, and it's done for completeness. So what we end up with here now is this here, the crow's foot, is the many side of the relationship occurs over here, and the foreign key occurs over here. In your own time, deduce it, and you will see that it actually makes sense, because stop looking at this as an entity and look at it as a table with rows. And each row is an entity instance. In this case, the proper name is a tuple or a row. But each row is an instance of the employee. And what we started off by saying is an employee can fill only one position. But looking at it from the other side, a position can be filled by many employees. That's what we had originally, wasn't it? And if you actually look at it now, in this table, because this here becomes a table, because an employee can only fill one position, you put that inside there. So when you look at the employee and you join it and you do whatever you do in whatever relational database you're using, you can easily know what position the employee is in. Previously, because an employee could have filled many positions and the position could have been filled by many employees, we had to create an entirely new entity or an entirely new relation or an entirely new table to represent the possible combinations of employees and positions. I don't know if you picture what I'm saying. A little bit sort of, okay. When you actually do it, you will see. And when it actually begins to make sense is when you take this now and you create a table with this and a table with this. And you put the relationship in just as you do in Access. Okay, so we have completed the many-to-many. We have just completed the one-to-many. Now we're going to look at the one-to-one relationship. One-to-one relationships are denoted by a cardinality of 1 on either side, which is 1, 1. So in this case, we have a cardinality of 1. Now for argument's sake here, let's say this is 0, and in this case, let's use a 1 over here. Now, what this is saying is that an employee can fill only one position and a position must be filled. Actually, let me put it the other way around. Let's have it like this. 1 here and 0 here. Makes a little more sense. Which states that an employee must fill only one position and a position can be filled by only one employee. Makes a little more sense. Makes a little more sense. However, I'm just trying to demonstrate the fact that we have a one-to-one relation. Now, in most instances, when you have a one-to-one relation, one of these usually is can is must, and one is can. Depending on which is which, that determines which side you go. But you can go either side if you wanted to. It wouldn't dramatically change the design. What you have to bear in mind is efficiency in terms of implementation of the database. Because I can choose, just like before, because there is 1 there, to absorb that over here. I can choose that. And if I did that, I will have here once again a foreign key called position ID. And when I did that, I will get a diagram that looks like this here. Just 1-to-1, no crow's foot anywhere. Okay? So it's just 1-to-1. And position ID occurs over on this side. Alternatively, I could have done it the other way around. I could have had over here, FK. I could have had employee ID over there and taken it out from over here. This doesn't change much because it's a one-to-one relationship. However, in terms of implementation, it might be more advantageous to have the position ID here, or it might be more advantageous to have the employee ID over there. Whichever one you put it in doesn't really matter that much, but it must be represented in either one of the two. You do not create a new entity or anything like that.
Okay. So But must in the one that FK go to the one that had the must for the category?
Yes, that is the recommendation. Yeah, but you do not necessarily have to do it that way. You don't have to. It's just that it usually, when you, in terms of the assertions, remember this can and must comes from the assertions. When you actually read out the assertions, the must part, it makes more sense to put it over there because of the must. Because if an employee must hold a position, then it means that if I put a foreign key here as a position ID, when I create the employee, there must be a position for it. When you actually come to implementing the tables, you will see what I mean.
Okay.
And some relational databases will not allow you to have a foreign key such that if I have a position and this position is for it caters for an employee ID, but no employee exists that occupies that position, it means that this will have to be what we call null. And some or most relational databases will not allow you to have a null foreign key. That is why you use the must. There is a logic to it, but you know, it all depends on the implementation. That's why this view here is called the implementational view. Now, what we have dealt with here is the 3 different types of relationships that we can possibly have, and how to transform the ER diagram, the detailed ER diagram, into an implementable closed-foot relational model diagram. I have done it here on the board. And it's usually nice to have the detailed ER diagram, a printout of it, and you do a little rough sketch, and you end up, you have a rough sketch of your RM diagram. What I'm going to look at in the next class is how we do this here in Visio. Because Visio does allow you to create this, and you don't have to worry about foreign keys and moving them around. You just click and drag and the foreign key goes over with you as long as you do it properly. So that is what we're going to spend the next class looking at, dealing with this here in Visio.